everybody. I hope you had an awesome weekend. It looks like Maya is joining us live, so hello. If you guys didn't print out this lesson, which is totally fine, I don't expect you to have a printer at home. I myself don't own a printer. You can just take notes on some of the important bullet points of the lesson. So unit 7, lesson 1, we're going to talk about something called an even and an odd function. Your homework tonight is in Delta Math, so let me write that down. So homework is in Delta Math. It's due on Wednesday because that'll be the day of your next lesson. Hi, Maya. Hope you had an awesome weekend. I'd show you my puppy, but he's taking a nap, and he has been hyper all morning, so I'm going to relish this nap while I can. So, it says, recall that functions are simply rules that convert inputs and outputs. These rules then get placed into various categories since for example, linear, exponential, and quadratic, etc. And today we're going to look at some of the characteristics of different functions. So the important part here on this page is what an even function is and what an odd function is. So a function that is known as even, my highlighter's not very thick, is it? Boom, let's try that. All right. A function is even if this happens. Your input, so f of negative x is equal to f of x for every value of the domain f of x. Sorry, you're going to hear a lot of background noises because my husband sent out a ton of emails and now his students are replying. So a function is known as odd if this occurs. So what does all this fancy notation stuff mean? So when x is negated, y stays the same. So that's what all that junk up there means. Oops. Keep choosing the wrong color. Come on, Sadler. Get it together. All right. So when x is negated, y stays the same. If those points occur, then you have something called an even function. If you have an odd function, what all that jibber jabber means up there is when x is negated, y becomes opposite. So for an odd function, when x is negated, the y becomes opposite. And so we're going to look at what all that means graphically too. If you need me to slow down, just comment like, hey, Sadler, you're going too fast. Oh, we got some more viewers. Who else is joining us in here? Hi, Justine. So you haven't missed too much yet. We're just going over what an even function is and what an odd function is. So those are the formal definitions are in the box, but I like to write my own definition below. All right. So we have a partial graph of some functions below. So we want to graph A as an even function. So it gave us some points that are already plotted. We have the point 0, 0, we have the point 3, 5, and we have the point 7, negative 2. Well, based on that definition, when x is negated, the y stays the same. Well, 0, 0 is not going to change, but if we look at the next point, 3, 5, that means if it's an even function, sorry, I'm going around this microphone that's blocking me, that would be the point negative 3, 5. So 1, 2, 3, 1, 2, 3, 4, 5. And if we have the point 7, negative 2, if I negate the x, my y stays the same. We're going to have the point negative 7, negative 2. So 3, 4, 5, 6, 7, and then down 2. And then we can connect these. Very good. So that's an example of an even function. We see some points and we can see it visually. For an odd function, it gave us some points. And it says when x is negated, y becomes opposite. So 0, 0, that's not going to change. But 3, 5 is. That's going to really become the point negative 3, negative 5. So negative 3, 1, 2, Let me zoom in a little bit here so I can count better. 1, 2, 3, 1, 2, 3, 4, 5. And the point 7, negative 2, those are both going to change. That's going to be negative 7, positive 2. So those are both examples of even and odd. So if you don't have graph paper, that's fine, but make sure you do write the points down. So if we want to check out some of the graphical features of this for even, if you look at that, it looks like the letter M, but it reflects, it has symmetry. The reflector has symmetry over the y axis. And then for odd, it reflects over the origin. So those are some graphical features. I gotta fix that one line. It does not look good. It's a little better. All right. So even reflects over the y-axis and odd is through the origin. So all of that stuff on the front page, my definition, the graph and the points, and this part C, that you're all going to need for your homework tonight. And again, if I went too fast, hi Madison. If I went too fast, feel free. I'm going to upload this to YouTube around 3 today, or you can always rewatch this video on Twitch too. So you can always go back to something that I might have went over too fast, or just let me know in the chat, you know. Okay, so let's scooch. Let's go to an example. So consider the function f of x equals the absolute value of x minus 4. So let's graph that. So that means I'm going down 4, 1, 2, 3, 4, and then I'm going out. So if you don't have graph paper, you just sketch this. This isn't a bad one to sketch. I moved my line. Ah, my pen froze. Good times. Good times. Come on, pen. Ooh, okay, there we are. So it says evaluate the function for a variety of input pairs. What is the even, odd, or neither? So we look at this. It has symmetry over the y-axis. So if we go back up here, it must be even. So it's even. We have symmetry over y-axis. So it says sketch. Oh, we already sketched it. Does it have the correct symmetry? So if we want to think about this, the definition, let me go back up here. The definition says for an even function, when x is negated, y stays the same. So let's see if that's true algebraically. So if we have f of x equals absolute value of x minus 4. Absolute value of x just means distance from 0, so we really have x minus 4. So I want to try this if I have f of negative x. If I plug in a negative x into this, will I still get the same answer? What's the absolute value of negative x? It's just x. So therefore, they're the same. So we can also check these algebraically as well. So we did graphically, algebraically, we can look at points. It'll all tell us if we have an even or an odd function. So let's try another one. We have a cubic function. We have g of x equals x cubed minus 4x. So we got to fill out our table of values. We can plug it in. You can use, if you don't have a calculator at home, you can use Desmos, and it'll pull up a table and a picture for you and all that sorts of fun stuff. So if you go to desmos.com/calculator, if you need a calculator later, that'll help you out. For now, I'll give you the points. Negative 15, 0, 3, 0, negative 3, 0, 15. So those are our table of values. And let's go back again to that definition for even and odd. Excuse me. Even is when x is negated, y stays the same. And when we had odd, they both pretty much changed the sign. So when x is negated, the y became opposite. So if we look at our points here, we had -3, -15, but then I also have a pair of points that says +3 and +15. So we can see that when x was negated, the y did change its sign. And we can see that in another pair of points. We had -1, +3, and then I have +1, -3. So we can see that both signs are changing. So this is looking like it's going to be odd. So odd, both x and y change signs. So that's how you can tell it from a table. If I want to show this algebraically, because, you know, why not show it algebraically? We are in Algebra 2. Let's plug in a -x and see what happens. So our original equation was +x³ minus 4x. So if this is an odd function, we should get a final answer of -x³ plus 4x. Both of those should change. So let's see what happens. If I do g of -x, we get -x³ minus 4 times a -x. And that's going to give me -x³ plus 4x. So therefore, since it's opposite, I drew a triangle. I'm not sure how that happened. Since it's opposite from the original, it is odd. It's going to be odd. So then let's also check this out graphically. It should reflect through the origin. So let's graph some of these pretty points, and we're just estimating here. So we have 0, 0 as a point. We have -1, +3. We also have +1, -3. We have -2, 0, and +2, 0. And then we have -3, -15, and +3, +15. So my drawing is slightly crude, but we can see that opposite effect of both points. So like that -3, -15 is directly opposite through the origin to +3, +15. We can see that -1, +3 is directly through the origin at +1, -3. So we can see that relationship. So that is what you'll need to be able to do your homework tonight. If you have any questions, don't hesitate, email me, Zoom me, whatever you want to do. I do have, technically my afternoon is pre-calculus office hours, but it's normally not too busy. So if you want to Zoom me from 1 to 3, that's fine too. So I hope you all have a fabulous day. If you do join me on my office hours, you will have the pleasure of meeting Archimedes, Archie, my corgi puppy that we just got over the weekend. So keep that in mind, do a little math, see an adorable puppy, whatever you want. So yeah, any questions? I know my stream is slightly delayed. Do I need to go back up to anything? Hi, Madison. Or are we sitting pretty? Okay, looks like we're doing good. So I will see you guys later. Again, I'll go live on Wednesday at the same time. Bye.